Swayam Prabha. Digital India. Educated India.
Okay. So, let us download this delay info forecast.mdl model and let us see what kind of graphs we get when the actual sales rate is 100 plus step of 10 comma 10, 100 plus 50 into pulse of 10 comma 1, and what if sales is normally distributed around a constant mean. See, these are typical scenarios happen. The first two cases are just to understand how the dynamics work, but in reality we expect that the demand keeps fluctuating around a constant mean, right. So, we are assuming normal. So, in that case let us see how to simulate that scenario also. Let me quickly show the forecasted demand is 100, the actual sales is 100 plus step of 10 comma 10. Step of 10 comma 10 means at time 10 there is additional unit of 10. So, from 0 to 10, 0 to time 10, the actual sales and the forecasted sales is exactly the same. So, we do not expect any dynamics to happen. So, system will start at dynamic equilibrium. Smoothing constant is 0.2. So, at every time period 20% of the difference is going to be added to the stock. So, stock has to keep increasing, right. So, that is what you expect. So, if we simulate the system, the forecasted demand follows a simple exponential goal seeking process, because the system that you just saw is nothing but a goal seeking model, where instead of having a desired stock we called it as a reported value or the actual sales, and as a goal changed I am going to approach that new value of the goal and saturate at 110, correct. Here note that the material is not conserved, that is, let me show forecasted and actual sales. If we plot them, the actual sales increased to 10, 110 and held constant there, but here you can see the forecasted demand slowly approaching 110, and after some point it will be the same, but whatever happened in this transient period is lost, like meaning no material is conserved there. The information was used to adjust my forecasted demand, but beyond that I am not using that information again. So, that is what we mean by flows are not conserved. Maybe it will be more apparent when we do the second option. What was it? 100 plus 50 into, let me just copy this. Yeah. So, now I am just going to the actual sales rate and replacing with 100 plus 50 into pulse 10 comma 1. So, what has happened is at time 10 there is a pulse of 50 units, there is at only one period there is abnormal, suddenly demand peaked additional 50 units. So, the actual sales, there is a red line, went from 100 to 150 for just one period and came back, but since we are reacting, the next period I added 20% of difference. So, it went to 110 and the next period I saw it was still only 100, then I slowly started to revise it downwards until I hit my goal. So, I never hit 150, I only go little way up and then I just slowly come back to the old goal. Okay. Again, this is just simulation, right. So, it does not know what is going to happen, it cannot estimate until it actually sees the value. Now, let us go to the third one. In third case, we want to do something called random normal. Before we do that, so whenever new things come, I expect you to, I am just showing it because you will also learn. how to do there are various functions like the one if you want to simulate random distribution or Poisson triangle, various distributions can also be given here. So, in demand typically we model as normal distribution or exponential distribution or various distributions. Some of it can handle. So, let us see, do I get a random normal is what we want. Random normal, though mathematically we just give 2 parameters, for simulation purpose it looks like it wants 1, 2, 3, 4, 5 different parameters. By default it gives normal distribution mean 0 and variance 1. H is the mean, R is the standard deviation in this third and fourth parameter, mean and standard deviation. What is M? M looks like the number of samples. Let me go to random normal itself. M is the minimum value it will return, okay. X is the maximum, okay. So, M and X gives a minimum and maximum for a truncated normal distribution, what it gives. So, you can't give it minus infinity plus infinity. If you really want it, then you give a really large number positive and really large number negative. So, minimum value, maximum value, mean, standard deviation, and S I think stands for seed number. So, that when you run it multiple times, we generate the same random number. That is enough for now. So, let us go back. So, minimum is 0, maximum 500 we have kept, mean is 100, standard deviation 25 we have been given, we just put a stream as default value as 1. So, let us simulate, only let us plot the sales, you will get a curve like this, it is randomly distributing, the mean is approximately 100 as per this, which is what we expect, right, mean is approximately 100. Because of standard deviation, that is a noise, we are going to get a fluctuating values of sales, it looks more realistic. Now, let us do forecast and this together. The green line in the middle is the forecast. So, as you can see, it is doing exponential smoothing. So, it is not going to go to the extremes because it is only 0.2. You get the green line like this, it does not react so much to the demand pattern. If we change the alpha value to something larger, let us see that. Let us see what happens when we change the demand value or smoothing constant to something larger. Instead of 0.2, let us consider 0.8. Okay. Simulate over right now, current 0.8. Yeah, you can see 3 lines. The red line, this one, wherever the mouse is, the red line is the actual demand. There is a, I do not choose the color, so the orange line seems like this is 0.2 and the blue line is with 0.8. 0.8 more faithfully follows the same pattern because you are going to weightage of 80%, so it is going to follow the same pattern. If you do not want it to react so much to the deviations, then we try to hover around the mean. So, let us go back to the slides. Now, let us take up another example. Availability of job openings influence people to migrate to a city, and as people migrate to a city, they fill the available job openings. The simplistic SFD is shown here. People, then job openings, migration, adjustment time. Do you think that this represents the description given? The first question. The availability of job openings influence people to migrate to a city. As people migrate to city, they fill the available job openings. As migration happen, people come in, then we have set of jobs. Right. As per this model, what should be the units for people? as per whatever is given in stock flow diagram. People unit could be person, job units could be job. So now what will be units of job openings? Oh, I am just taking the difference. The structure is exactly the same. So I have to difference between, as per this, its jobs minus people. So there it will get a dimension mismatch. And job opening, even if is converted into jobs, then migration, as per this, it should be person per time. Correct. So migration should be person per time. But job opening somewhere, I am just using the jobs. So I need to actually have another variable called as jobs per person or something like that, or person per jobs, either way. So whenever there is a model, you see, we will do three things. We open the model, check the model settings, check the start time, check finish time, text time step, very easy. Then you check the value of constants and equations, and then check whether it is dimensionally consistent. So I am going to show all the three steps. What is the name of the file again? Job space. Okay. If you go to model settings, we will find the initial time is 0, final time 50, time step is 0.25, units for time is month, fine. People, about 800 people are there initially, units is persons, then job, 1000 people are, 1000 jobs are there. But then when I came to job openings, I just put the unit as job, so jobs minus people. And then when they went to migration, I just did it as job openings divided by adjustment time. Very simple model. You can and the way it is structured is exactly same as the previous two examples. One we drew on the paper or one we just saw. It's exactly same format. But to check the units, if we do model units check, it will say there are two unit errors discovered. The first one is error in units for following job openings equation. Other is error in units for following migration equation. Because job openings had job minus people, that means job unit and person unit are taken difference, and then final unit you have said as jobs, it says it does not match. That is one. Oh, another thing while we are here, I think I should just. Okay. So, in your can I say in your Vensim model, there is some button here called as document all. So, if you click that button, it will give the entire model along with the settings in equations form. It shows a variable adjustment time too, with what is units, what is the final time, what is the initial time, what is the time units, then the equations, job openings, jobs, migration, people. In this, how can you figure out which is the stock from this? Let's be able to see it. Whichever one has integ function is the stock, and whatever is integrating it over, it must be the flow. Right. So that's how you find it. Okay. Now, let's. So this is a model we have. Let's see what we have to do to change it, and then I will show how to change it. So now we have to make the model dimensionally consistent. Let us introduce a variable called as persons to job ratio. Unit is persons by job. Let us introduce a new variable and connect it to person, connect it to job openings and connect it to migration, so that now I can make it dimensionally consistent. So I am going to introduce a person to jobs ratio, or people to jobs. Let's just okay. people to job ratio. Let me connect it to migration as well as this. These are two equations which requires changing, so I am just connecting it to them. As soon as you click f of x, all three is going to go black. Person to job ratio, let's call it person by job. Let's just say one person equal to one job for simplicity's sake. How will I change the job openings equation? I need to convert it into units of jobs. So, I will say job minus people divided by people to job ratio, right. And here I can check syntax. Oh, it went to the next equation, okay. Just close it. Fine. And then I go to the next equation, migration. So, migration I just need to multiply jobs to people ratio, because job openings are in jobs. So, when I multiply it, it will come back into people. Okay, let us do model units check, all units are okay. So, I just made it dimensionally consistent. Again, when I get a one example, I try to use in couple of other ideas so that both the jobs are done. So, now if I simulate it, okay, what was the initial values? The people initial value was 800 and job value was 1000. Since people to job ratio is 1, it is kind of equivalent. So, I just simulated it. So, let me select people and jobs and make a different graphs. So, people and jobs remain constant at jobs remain constant at 1000. People migrate and go from 800 to 1000. Okay. So, this is a very simple model of a basic delay. Now, let us make that example little more interesting. Any questions on this far? All I just made was dimensionally consistent, but other than that the structure did not change from the previous demand example. Demand example looks like a very constructed and structured example, seen other courses also. But this one looks like we are talking about migration, other stuff, but finally the basic structure is very similar.